Today we are discussing arguably the world's most valuable currency, AI credits. You've probably seen it before. That little message when you're using an AI platform. You've used 80% of your credits. Or maybe you've bought some API access from OpenAI, Anthropic, or Google Cloud and realized those credits are more than just virtual tokens. They're the fuel that keeps the world's most powerful machines thinking. AI credits aren't just a billing system. They represent compute, energy, and scarcity. Every question you ask an AI model consumes resources, electricity, GPU time, cooling, and bandwidth. And together, they form the invisible economy of intelligence. Today, we're going deep into this hidden world. What AI credits actually are, how much resources they consume, and why they're becoming one of the most valuable currencies of the digital age. So let's dive in. Chapter 1. What AI credits actually represent. Let's start with the basics. An AI credit is not a coin, not a cryptocurrency. It's a unit of computation. When you use an AI model like GPT-4, Claude, or Gemini, every input and output consumes compute time on a massive cluster of GPUs or TPUs some companies abstract that cost into a simpler system. Credits. One credit might equal, say, a few hundred tokens processed or a few seconds of compute. The idea is, instead of saying you used 0.000002 GPU hours, they just say you used 1 credit. But behind that abstraction is a very real infrastructure. When you send a request to an AI API, it travels to a data center, often filled with NVIDIA 100s or A100s. Each of those GPUs can cost anywhere from $25,000 to $40,000, and they draw 300 to 700 watts of power each. Now multiply that by tens of thousands of GPUs running 24/7. That's what a credit really represents. A small slice of that compute time, that electricity, and that hardware wear. So, when you spend AI credits, you're literally renting a fraction of the most powerful computing hardware on Earth for a few seconds at a time. Chapter 2. The real cost of intelligence. Okay, let's talk about resources. Because AI isn't magic. It's physics, it's math, and it's energy. Training and running these models consumes massive amounts of resources. For example, training GPT-3 was estimated to consume around 1.3 gigawatt hours of electricity, enough to power hundreds of homes for a year. GPT-4 is rumored to be several times more expensive, and that's just training. Inference, which happens every time someone prompts the model, also adds up. Each prompt might consume only a fraction of a cent in electricity, but multiply that by billions of queries per day across all AI systems, and you're talking about terawatt hours of energy annually. That's the hidden cost behind your free ChatGPT conversation or image generation. And here's the kicker. As models get more capable, they also get hungrier. Bigger context windows, longer outputs, multimodal inputs, all require more compute. So when companies give you a few thousand free credits, they're basically subsidizing your access to supercomputers. But make no mistake, those credits are backed by some of the most expensive infrastructure humanity has ever built. Chapter 3. The GPU Gold Rush. Let's talk about the hardware that makes AI credits valuable, GPUs. Right now, there's an arms race for compute. NVIDIA, AMD, Intel, and even startups like Cerebras and Graphcore are all building chips designed to handle AI workloads. But the market leader, by a mile, is NVIDIA. Their data center division, driven by GPUs like the A100 and H100, is printing billions in revenue each quarter. Why? Because every major AI company, OpenAI, Anthropic, Meta, Google, Amazon, needs enormous GPU clusters to train and serve models. Each GPU cluster might have tens of thousands of chips, connected by high-speed networks, cooled by industrial systems, and powered by megawatts of electricity. The result? We've entered what some call the compute economy. And AI credits are how that economy is monetized. When you buy AI credits, you're buying a slice of compute that these GPUs provide. The more demand for AI, the more valuable that compute becomes. So, in a way, AI credits are derivatives of GPU time. Just like oil futures represent energy, AI credits represent intelligence capacity. And right now, demand is exploding. Chapter 4. The economics of AI credits. All right, let's get into the economics, because this is where things get fascinating. AI companies have to price credits carefully. Too cheap, and they burn through cash. Too expensive, and people won't adopt the platform. Take OpenAI as an example. They price GPT 3.5 Turbo at around 50 cents per million input tokens, while GPT-4 Turbo is about $10 per million. That's a 20 times difference, but people still pay for GPT-4 because the quality is worth it. This difference in credit pricing reflects not only model complexity, but also the cost of inference. How many GPUs, how much memory, and how long it takes to generate a response. And here's something most people don't realize. AI credits are an elastic resource market. When demand spikes, like during a product launch or viral trend, compute availability becomes the bottleneck. In extreme cases, that can even cause API throttling or queue delays because there are literally no spare GPUs available at that moment. So, AI credits could someday behave like digital commodities, with variable prices, futures markets, or even decentralized exchanges. Imagine trading compute time the way we trade energy. That's not sci-fi. There are already startups exploring compute marketplaces where you can rent or sell unused GPU capacity for credits or tokens. Chapter 5. Energy, emissions, and ethics. We can't talk about AI credits without talking about their environmental footprint. Because the more compute we use, the more power we consume. And not all that power is clean. Data centers are improving efficiency. But the demand for AI compute is growing faster than renewable capacity in many regions. A single high-end GPU cluster can draw tens of megawatts, roughly equivalent to a small town. Cooling that heat requires water, air conditioning, and advanced heat exchangers. So when we talk about the cost of AI, we're not just talking about dollars. We're talking about carbon and climate. Some companies are working to offset these emissions. Google claims its AI infrastructure is carbon neutral, and others are moving toward renewable-powered data centers. But it's an open question whether the exponential growth of AI demand can stay sustainable. Because every new credit, every prompt, every image, it all adds up to real energy drawn from the grid. Chapter 6. The value chain. Let's zoom out for a second and look at the value chain of an AI credit. Who gets paid and for what? Here's what happens behind one credit. You send a prompt to an AI platform. That request gets routed to a cloud provider like Azure, AWS, or Google Cloud. The cloud provider allocates a slice of GPU time from its cluster. NVIDIA, or AMD, etc., profits from selling that hardware. The data center pays for electricity and cooling. The AI platform takes a margin for model access and infrastructure management. So your 1 cent worth of credit travels through a whole economic chain before it becomes an answer on your screen. And as AI systems become embedded into everything, from video editing to customer service, that chain becomes the backbone of the next digital economy. AI credits, in essence, are the currency of intelligence as a service. Chapter 7. Scarcity and the future market. Now, here's a wild idea. What happens when compute becomes scarce? We're already seeing this. GPU shortages, waitlists for AIAPIS, and cloud compute rationing for startups. Like when you try to generate an image, but the generation doesn't commence immediately. Compute is the new oil. As AI models grow, so does the competition for resources. Big players like OpenAI, Meta, and Google are vertically integrating, building their own data centers, custom chips, and exclusive compute deals. That means smaller developers might face higher costs or limited access to compute credits. Some people are predicting the rise of AI compute markets, places where companies and individuals can buy, sell, or lease compute time, almost like an energy grid. Imagine being able to tokenize your idle GPU time and sell it as AI credits to others. Projects like Golem, Akash, and others are already experimenting with this. It's the beginning of what some call the decentralized compute economy, where AI power isn't monopolized by a few giants, but distributed across networks like Cloud Computing 2.0. Chapter 8. The Human Value of Compute. Let's shift gears for a moment, because while we've been talking about hardware and economics, AI credits also represent human value, creativity, problem solving, and time saved. Think about it. If I can use a few credits to generate code, design a product mock-up, or summarize a book, that's hours of human labor condensed into seconds. So while the infrastructure cost is measurable, the value extracted per credit can be exponential. That's why AI credits are so powerful. They convert energy into knowledge, electricity into insight, hardware cycles into creativity. That transformation is what makes them more valuable than the sum of their parts. In the future, you might budget not just for dollars or hours, but for compute credits, the amount of intelligence you can afford to deploy. It's a strange but fascinating shift, where access to compute becomes a form of empowerment. Chapter 9. The Coming Era of Compute Sovereignty. Now, here's where things get political. As AI becomes critical infrastructure, countries are starting to view compute as a matter of national security. The U.S. has restricted exports of advanced GPUs to certain countries. Nations are building their own sovereign AI clouds to reduce dependency, and some are even measuring their AI readiness based on available FLOPS per citizen. This is the geopolitics of compute, where AI credits might one day be as strategic as oil reserves. So, when we talk about AI credits, we're not just talking about software subscriptions. We're talking about global power structures. Chapter 10. The Future. So, where's this all heading? In the next few years, I think we'll see AI credits become even more standardized, almost like an API currency. You might have a universal AI wallet, where credits can be used across platforms, OpenAI, Anthropic, Google, local models, and more. We might even see interoperability protocols, so you can seamlessly spend compute wherever it's available. We'll also see more transparency, maybe even carbon accounting per credit, showing you the environmental footprint of your compute usage. And as models become more efficient, we might eventually decouple performance from power, so each credit gives you exponentially more capability. But make no mistake, compute will always be scarce, because demand for intelligence grows faster than hardware can scale. So whether it's through subscriptions, marketplaces, or tokens, AI credits will remain the unit of value behind everything intelligent. Outro. So next time you see that message, you've used 80% of your credits. Remember, those credits are more than just numbers. They represent electricity, silicon, and human creativity, all converging into a single output. AI credits are the hidden currency of the future, the bridge between energy and intelligence. And understanding them might just be the key to understanding the future of our digital economy. Thanks for watching. if you enjoyed this deep dive and you believe in AI ethics. Leave a like and subscribe for more information about AI danger.